Hello and welcome to today's science lesson. So first of all, guys, can we all turn to wave and say a big hello to our friends on camera? Hello. And we'll begin by doing our meditation sequence. So I will sit down, take 2 fingers, find our heart center, left hand on our laps and close our eyes. And when you're ready, guys, you can open your eyes and come back to the room. And next, we'll do our stretch sequence. So let's stand up and push in our chairs. And we can begin by stretching up high to the sky. High as we can. And then let's go down low. Touch our toes. Back up high one more time. And this time, can we go tippy toe high? And while we're there, let's have a wave side to side. And now, let's go forwards, backwards, forwards, backwards, forwards, backwards, and stop. And now hands on hips, have a wiggle side to side. Stop. Another wiggle side to side. Stop. Forwards, backwards, forwards, backwards, forwards, backwards, and stop. And now we'll go round and round. Round and round. Round and round. And stop. Now we'll go back the other way. Round and round the other way. And stop. And to finish, we'll do 5 claps. 1, 2, 3, 4, 5. Excellent, guys. Have a seat. So in math class recently, we've been doing a lot of work on the subject of matter. So let's write that word on the board first. Matter is M-A-T-T-E-R. Now remember, matter is the thing that is all around us. Everything on this planet and everything in the air is made up of at least one different type of matter. Now, who can remember the 3 types of matter, guys? Solids, liquids, and gas. And in our previous lesson, we concentrated on one particular type of matter. Can anybody remember what that was? Solids. Well done, Pak Bung. Yes, we learned about solids and their properties and characteristics. Solids is spelled S-O-L-I-D-S. So altogether, matter, solids. Now the first thing we learned about with our experiments, we learned about shape. Yes. Now remembering about shape, do solids change shape when we put them into different containers? Remember when we had the bowl and the box, and then we even tried squeezing them? Did the shape of the solid objects change, guys? No, that's correct. They stayed the same because the shape does not change. solid object shape does not change when we change the environment. For example, this marker pen, I have it in my hand here. It's this shape. If I put it into this pocket, does it change shape? No, it stays exactly the same. All solid objects do not change shape. That's what makes them solid. And the other thing we looked at, after shape, we looked at size. When we moved the objects from the smaller bowl into the larger box, did they get bigger? No, they stayed exactly the same. So that means that solid objects' size does not change either. Not change. Yes, these are the characteristics of our solids. Shape does not change. Size does not change. And then remember, we did one more experiment when we took the objects and we tried to squeeze them. We tried to make them smaller or stretch them. What we tried to do is we tried to change the volume. V-O-L-U-M-E. So remember, guys, when you try to squeeze the objects, did they change shape, size, or volume? No, they stayed perfectly the same. So volume also does not change. Yes, these are the three characteristics of solid objects, such as this marker pen. Shape does not change. Size does not change. And volume does not change. And then later in the lesson, we did a worksheet activity for our students to recognize what solids are. So what I'm going to do now, I'm going to go round the room and ask each student, and they've got to give me an example of one solid object. And we'll begin with Lak Gao. So Lak Gao, have a look around the room. Can you think of a solid object at all, as long as it's solid? You might even be sitting on one now. Computer. Okay, computer is an example of a solid object. C-O-M-P-U-T-E-R. Bangpon, how about you? What's your solid object? Can you think? TV. Okay, we've got the computer and then we've got the TV. These are all electrical goods and they are solid objects. TV. And how about Preo? What's your solid object, Preo? Pen. Good. Yes. The pen that I use now, solid. It's a solid object. Pen. How about down? A fan. Yes. The fan we use in the room to keep us cool. Solid object. Stu, what's your solid object? A ruler. Okay, very good. Ruler is solid. Nadia? Chair. Excellent. Chair. Yeah, air is the type of matter known as gas. So how about you, Pat? Do you have a solid object? Table. Okay, table. And then Pak Bung, what do you have? A book. Excellent. A book is a solid object. And finally, net. Pencil. Okay. Okay. Now let's have a look at all of our different solid objects. Computer. TV. Pen. Fan. Ruler. Chair. Table. Book. Pencil. If you look at them, all them different objects, they all share these characteristics. Shape does not change. Size does not change. And volume does not change. All of these things stay the same wherever we put them and however we treat them, because they are solid objects. And guys, that was very well done, well remembered. And what we're going to do in today's lesson, we're going to move on slightly. We're staying with matter, but we're finished with solids for now. We're going to move on to the next state of matter. And the next state of matter is liquids. So today we're going to learn about some of the properties and characteristics of liquids. Some of them are similar to solids and other ones aren't quite as much. And we've got a practical activity for our students to learn more coming up. But first of all, time for our PowerPoint presentation. So let's turn to look at the TV screen, guys, to observe, listen, and practice speaking about liquids. So let's take a look at our PowerPoint presentation about our next states of matter, liquids. And you can see in the picture here that we've got an example of one type of liquid. Can anybody guess what it is?
Water.
Yes. Probably the most common liquids we will ever see. In fact, our entire planet is made up of 2/3 water. So the most common liquid you will experience is water. Liquid matter particles are packed close but not arranged in a fixed pattern. Yes, so remember the particles of the solid objects were very tightly kept together. They were packed very tight in a fixed pattern. Liquid particles are still close, but they're a bit looser. They're not as tightly packed as solid particles, and liquid particles can move around. That's why when you have a cup or a drink, if you move the cup, the liquid will move too. All liquids have no fixed shape, but do have fixed volumes. Yes, so remember, that's one of the big differences between solids and liquids. If we put a solid into a different container, the shape stays the same. But if we put liquids into different containers, the shape changes. The liquid will adopt the shape of the container. Liquids can flow freely from one container to another. And here we have a good example, because here in the larger container is what's known as a jug. And here we have the water being poured into the smaller container, the glass. So notice how here the shape of the water is the shape of the jug. But here, the shape of the water is the shape of the glass, because liquid will change shape depending on what container you put it in. Solids stay the same. Remember, we put the solids into the bowl, into the box, and they stayed the same. But later, we'll do an experiment with liquids, and you'll see the liquids change. Liquids will always take the shape of the container they are poured into. Yes, like I said previously, and this picture is a good example, because you can see lots of glassware, all different shapes and all different sizes, and some different colours too, so you can see better. And notice how each time the liquid is the shape of the container. That's what we mean by changes shape. Liquids can be touched, but they cannot be squeezed easily. So another difference with solid objects. With solids, we can just pick them up. Like a remote control or something, we can pick it up and hold it. But with liquids, we can't do this. What we can do is we can touch liquids, but we can't pick liquids up, because the water, or whatever it is, will just run through our fingers and we'll get wet. So although liquid can be touched, it can't be held on its own. That's why we need containers. Therefore, a liquid has a fixed volume, just like a solid does. Yes. And the liquid volume can change depending on the amounts. So here, in the larger bottle, is a 4-litre bottle of milk. This holds 4 litres. So if we want to pour this milk into 1 litre containers, how many do we need? 4, you see, because this is 4 litres, it fits in once. But the litres, they need 4 of them for them to be enough to fit this one. And that's what we mean by a fixed volume. If you put liquid into a cup, it becomes the cup. Now you can see here with the tea bag's still in the cup. So the tea and the water has become the cup. It's adopted the shape of the cup. But how about if we change the container? If you put liquid into a bottle, it becomes the bottle. And here we can see a picture of 6 different bottles of different sizes and different shapes. And notice each time the water just adopts the shape of the bottle. And then other containers too. If you put liquid into a teapot, it becomes the teapot. Now you can see here, a teapot is a strange shape. But notice how the liquid, in this case the water, always becomes the shape of the teapot. And here you can see bubbles. What's happening here is that the teapot is boiling. Someone wants a hot cup of tea, so they're boiling the water, and you can see the bubbles rising, and then you get steam. And this is what we'll look at in our next lesson. Steam is the next type of matter known as gas. So, liquids have a fixed volume, but not a fixed shape. Liquids can't be squeezed. Yes, one of the properties of liquids is that they're wet and they flow freely. So if we try to squeeze a liquid, we're not going to be very successful. Any questions, guys? Okay, that was excellent. Very well done. Welcome back to class. We hope your students enjoyed the PowerPoint presentation to learn more about the type of matter which is liquids and how they share some similarities with solids, but also some differences with solids too. And what we're going to do now is a practical activity for our students to understand more about the similarities and differences with solids. So what we need to do, teachers, is prepare a table just like this. And what you'll need is a bowl for the final activity, but then you also need 3 other containers of different sizes and shapes. So I've chosen a glass, a bottle, a glass, and also a plastic cup, because they're all different size for our students to tell if the shape and size of the liquid, which is water, will change. And for the final test, we're going to use the bowl. So you can use 3 different containers, it doesn't matter, as long as they're of different sizes, so that we can demonstrate the changes of the water. So let's write these 3 objects on the board first, guys. How do we spell bottle? B-O-T-T-L-E. And then we have glass. L-A-S-S. And finally, we have a plastic cup. C-U-P. And as you can see, I've chosen these 3 containers because they're all of different size. And the 3 tests we're going to be doing is the same ones we did for the solids. So first of all, we'll be looking at shape. We want to know if the shape of the liquids will change when it goes into different containers. And then we want to know about size. We want to know if the size of the liquid will change depending on the container that it's in. And then finally, we're going to look at volume. What we're going to do is we're going to try and see if our students can catch and hold the water and squeeze it. And if they can, they might be able to change the volume. But if they can't, they won't be able to. So we have our three objects, and now we need our first student to come forward and demonstrate each experiments. So Pak Bung, can you come and join me at the front of class, please? So now it's up to our first student to do the first demonstration of our practical activity. What I've done is I've prepared a bottle, and notice how I haven't filled the bottle to the top, because what I want Pak Bung to do is to give this bottle of water a shake. And let's see if the shape of the water changes as Pak Bung is shaking the bottle. So a nice big shake, please, Pak Bung. And there you can see the water moving around inside the bottle. So does the shape of the water change? What do we think, guys? Yes or no? Yes, it does. You see? The gap is here now at the bottom of the bottle. If I turn it upside down, no gap here, the gap is at the top. This shows how the shape of the water will change. So what we can do with the bottle is we can tick, there has been a change to the shape. So now what we're going to do is Pak Bung is going to pour the water from the bottle into a container of a different size. Now, will the size of the water stay like it is in the bottle, or will the size of the water change depending on the container? So Pak Bung, let's see. Excellent. Okay, now let me use the water in the bottle as a demonstration. Did the size of the water change, guys? Yes, you can see how the size of the water here is slimmer to fit the bottle. However, the size of the cup is wider, and once the water goes into the cup, it changes size to adopt the shape of its new container. So all liquids will also change size. So now it's time for experiment number 3. And this is the fun experiment, because what I'm going to do, I'm going to take the water that's in the cup, I'm going to pour it into the bowl. Pak Bung, try to catch the water. And if you can catch the water, try to squeeze the water. Remember with the solid objects when we try to squeeze. But the solid objects, we could not squeeze them. Let's see if we can squeeze the water. So hands over. Ready? Ready? Are you ready? Okay, can you squeeze the water? What's happening with the water? The water just runs through Pak Bung's hand, and the water will end up in the bowl. And then I can pour the water back into the cup. So did the volume of the water change, guys? There's no volume change to the water. Once we change the water between its different containers, nothing changes. So we say that water will not change volume. So the characteristics of water or other liquids, they change shape, they change size, but they will not change volume. Pak Bung, that was brilliant. High five and a big round of applause for Pak Bung, please, guys. And now it's time for our next experiment with our next student. So now I'd like to invite Dan to come and join me at the front of class. And this time what we're going to do, we're going to carry out the same experiments, but this time with the glass. And we're going to see if we get the same results. Because what should happen is that liquids should share the same properties and characteristics in each of the containers. So let's find out. So first of all, we have a glass about half full with water. What I'd want Dan to do, carefully, because it's glass, is I want Dan to move the liquid around in the water. And then we'll be able to tell, does it change shape or not? Because if it was solid, it wouldn't change shape, remember? But how about a liquid? So Dan, that's for you. And show it to the camera. And can you tilt it side to side? Is the liquid moving in the glass, guys? Is it changing shape? It certainly is, you can see. And maybe if we do it a little bit more like this, being careful not to spill, look at the shape of the, does it change? Yes, and then if we go this way, does it change? That's because it's a liquid. All liquids will always change shape depending on the container that they're in. So once again, we've got a tick for change of shape. Now, what I want down to do is do the test around the change of size. So what we've got is we've got liquids such as water in a glass. Now I'd like down to pour it into the cup. And let's see, or if you want, down, if you're really careful, you can try to get some more into the bottle. Brilliant, Dan, very well done. Okay, so we've seen the shape of the glass, and we've seen the size of the glass. Now what's happened to the size of the water now that it's gone back into the bottle? Has it stayed the same? No, it's changed. The size of the water has changed from the size of the glass to the size of the bottle. And you can see, especially at the top, where it starts to get thinner. So all liquids will change shape and size depending on their container. And now it's time for our final test. Now I need to put some more water back into the glass. And what I'm going to ask down to do, like I did with Pakbund, as I pour the water from the glass into the bowl, I want down to try to grab it, try to hold the water or the liquid, because if it was a solid, we would be able to hold it and squeeze it. So let's see, Dan, can you grab the water? Are you ready? But you see what's different from the solids? With liquids, we can't grab them. We can't hold them. They'll just run straight through our fingers because their particles are not as close together. And what we can see is that the water that went into the glass and the bowl now goes back into the glass. So did the volume change? Volume didn't change. It was exactly the same as it was. We put it into the bowl and then we place it back into the glass. So once again, we can say that the volume of the liquid water in the glass will not change. So that's 2 tests done, and so far all liquids are adopting the right standard. Dan, that was brilliant. High five and a big round of applause for Dan, please, guys. And now it's time for our 3rd and final experiment with our water in the final container, which is the plastic glass or the plastic cup. And now I'd like to invite Lakgau to come and join me at the front of class. Lakgau is going to carry out exactly the same practical tests that we've done with the bottle and the glass. We want to see if there's a change in shape, a change in size, and a change in volume. So first of all, we have our water in the plastic cup. Lakgau, can you move it about slightly, but carefully? And show it to the friends. What can we see, guys? Can we see the shape changing? Yes, it's a liquid. All liquids will change shape depending on the shape of the container. You see, as I move it around, not very carefully, you can see how the shape is changing. Liquids will change shape depending on their container. So, once again, as we expect, we've got a tick for change of shape. Yes, it does. Now, I want Lakgau to investigate if there will be a change of size from the plastic cup into the glass. So now, Lakgau, can you pour your water from the plastic cup into the glass? Okay, well done. Now look at the plastic cup and look at the glass. Different sizes? Yes. The glass actually fits inside the cup. But notice how the water now, if I put the inside the glass, inside the cup, it keeps the shape of the thing it's in, the glass. So that means that the liquid will also change size, which is exactly like we expect all liquids to change shape depending on the container and also change size depending on the container. This shows how they are different from solids. But the one thing that solids and liquids all share is that they will not change volume. And we'll demonstrate again now. So Lakgau, are you ready? What I want Lackout to do is to try to grab the water again, so that the volume that goes from here into the bowl and back again, will it change? So here we go. Can you grab any? Show your hands up to the camera. Lackout hasn't been able to grab the liquid because it's run right through her fingers. And now, if I take the liquid and I just pour it back into the glass, did the volume change? No, the volume is exactly as it was at the start. So we can now see how the volume of liquids will not change, which is similar to solids, but the size and the shape of the liquids will change, which is different to solids. Like that was brilliant. High five and a big round of applause, guys. And now it's time for our stretchy activity. So guys, let's stand up and push in our chairs. For this activity, we'll do some rotations. Left, right, left, right, left, right, left, right, left, right. Excellent, guys. And now we'll take our right hand and try to find our left foot. Then left foot, right hand, left foot, left hand, right foot, right hand, left foot, left hand, right foot. And then let's shake it out, guys. Arms and legs, shake it out. And then we'll do 5 stretches to our right. 1, 2, 3, 4, 5. And then 5 stretches to our left. 1, 2, 3, 4, 5. Excellent. And to finish, we will do 5 claps. 1, 2, 3, 4, 5. Excellent, guys. Have a seat. And now it's time for our worksheet activity. So teachers, make sure all of the children in your classroom get their own worksheet. And the worksheet is very similar to the one we did for solids. But today, guys, we're not looking for solids, we're looking for liquids. So what we want our students to do in today's lesson is try to identify the pictures that show the liquids. So if you can identify the pictures that have the matter liquids, we write, this is a liquid. And the phrase is at the top here. But if you see the other states of matter, solids and gases, we will write, this is not a liquid. So give our students around 12 minutes for this activity and just monitor the class, help them with anything they need. And what do we need to write on top, guys? Write our names on top. So Net, this one's for you. Pakboom for you. You're welcome. Pat, here's yours. Nadia for you. You're welcome. Pew for you. You're welcome. Down, this one's for you.
Thank you.
You're welcome. And Parel, here's yours.
Thank you, teacher.
You're welcome. Bangbon for you.
Thank you, teacher.
You're welcome. And Lakgao, you're welcome. So names on top, guys. And try to remember from the last lesson, which ones are the solids? Because the solids cannot be liquids. You need to identify the liquids in today's lesson. So remember, the Lego block on the top, that was a solid. So we can definitely write, this is not a liquid. But what about the water? Last time we wrote, the water is not a solid. But how about a liquid? And if you need any help with anything, guys, let me know. The two phrases you need to write are at the top of the page. Well done, Pakbung. This is a liquid. And then this is not a liquid. Well done, down. Excellent, Prel. Remember, a good way to think about liquids, if we touch it and our hands get wet, it's a liquid. So if you think it'll make your hands wet if you touch it, that's one way to know it's a liquid. For example, the football. We won't get wet if we touch the football, so the football is not a liquid. Now that one, that's the one we learn about next lesson, in the sky. So this one, liquid, well done. This one, not a liquid. Yeah, that's the next lesson. That's a gas. Smoke is a gas. What do we think? And bubbles? Ask yourself, would we get wet if we touch that Pakbung? Yes, this is a liquid. Remember, liquids will get us wet. Correct, well done. The milk? Perfect, well done, Pakbung. Bang pon. Well done. Welcome back to class. We hope your students enjoyed the worksheet exercise, where in today's lesson they had to identify the liquids. And my students all did an excellent job here. Remember, if you're not sure if it's a liquid or not, think about our hands. If we touch it, would we get wet? If we would, that's a liquid. And that's all we've got time for in today's lesson. So we hope you've enjoyed it and now understand the characteristics of liquids. And we'll see you again soon for the next lesson. So can we turn to wave and say goodbye, guys? Bye-bye. See you again soon.